polar equations, so should be the same material. So the question was, they gave us these parametric equations. And they said, what is the slope of the tangent line to the curve when x equals 3?
Okay.
Okay. Well, we know slope is dy dx, okay?
Right.
So, first of all, we can't take dy dx directly. So, well, let's talk about this. Dy dx is going to be found by dividing top and bottom by dt. So it's going to be dy dt divided by dx dt.
Okay.
And notice we can find dy dt and we can find dx dt. So
Right.
let's begin by doing that. What's dx dt?
E to the t.
And dy dt.
Dy dt equals negative te to the negative t.
Okay, we got to use the product rule. In other words, we've got a variable in front and we've got a variable as part of the exponential. So
Okay.
y is really uv. So we got to use the product rule, okay? If we're using the product rule, then u is t, and then the
Right.
derivative of the next one is minus e to the minus t. But we got to add that to u prime v. Well, u prime is 1 v e to the minus t.
Okay.
Okay? So now we have our dx dt and dy dt. Let's figure out that. So it's minus t e to the minus t plus e to the minus t all over e to the t. Now we can factor out an e to the minus t up top. So what the top becomes is e to the minus t times minus t plus 1. Bottom, I got e to the t. So what does that simplify to?
Well, can we separate the top e into e to the t times e to the negative 1?
No, you don't want to redistribute it. We just went to the trouble of factoring it out. What you want to do is simplify that. That's the same base, different exponents. How do you do that?
I'm not sure.
Subtract the exponents. So e to the minus t divided by e to the t is going to be e to the minus 2t, which means it's going to be in the denominator, e to the 2t. The only thing left in the numerator is that, and I'm going to change it to 1 minus t. See how I did all that?
Yeah, I understand that now.
Now, that's dy dx. The thing is, the question says, what is the slope when x equals 3?
So we just plug in. Well, we can't plug in 3 to t, can we?
No, when x equals 3.
Okay.
The one thing you have to appreciate about these parametric equations, there's always 3 variables. even though a lot of times you can turn this into an XY equation where you just have two variables, when you're looking at parametric equations, that third variable is kind of hidden.
Okay.
In other words, you don't necessarily see it. If I were to graph these two parametric equations, you wouldn't see t. You'd see x and y. So, when x is 3, I'm going to solve this equation. When x is 3, what is t going to be equal to? How do I solve that?
Would you ln both sides?
Yeah.
Natural.
And so natural log of 3 is t. You with me?
Yep.
Excuse me. Yeah, no, that's right. When x is 3, t is natural log of 3. So down here, I know they're talking about the slope when t is the natural log of 3.
Okay.
So it's going to be 1 minus natural log, for some reason, natural log. I have a hard time writing it. ln of 3, that's t, e to the 2 natural log of 3. Can I simplify that? Can't simplify the top, but I can do a lot with the bottom. First of all, what can I do with that 2?
You can bring it out front.
Not out front, it's already out front. I can turn it into an exponent of 3. So it's really natural log of 9. In other words, it's the natural log of 3 squared.
Okay.
Let me do that because I'm running out of room to write here. And now what is e to the natural log of 9?
Would that be 9?
Yeah.
Because, yeah.
b to the natural log, or to the log base b of x is always x. So there's my answer. 1 minus natural log of 3 divided by 9.
Okay.
And that's what the slope at 3 is.
So I have a question. So it says at the point when x equals 3, would they ever do at the point when, like, would they give you a point, 3, -1, and then you have to plug in?
Yeah, and you can plug in either one.
Also.
If they gave you a 0.3 -1, then you can still calculate t, and it better agree with this t over here.
So it should be the same t.
It has to be.
Okay.
And when I give you these two parametric equations, t, the only thing we know about t is it's positive. Had they said, what is the slope when t is 2? Then it's real easy. There's our equation. Just substitute 2 for t.
Right.
And then you'll have t for 2. No. Okay. We done with this problem?
Yeah.
All right. Let's look at the other one you sent today. This one right here. I think I can work with that. Use a graphing utility to sketch the curve. Be sure to indicate orientation. Again, we have two parametric equations as a function of t. Both of them. And they tell you what t is going to do. It's going to go from 0 to 10. Now, the one thing you do not see when you graph two parametric equations, look at my bar. I got both parametric equations up there.
Yeah.
That's the curve, but that's an XY curve. T isn't on there.
Right.
But I know that t goes from Hold on. I know t goes from 0 to 12. The one thing that I don't get on this curve that they want from us is the orientation. In other words, which direction is it going?
Right.
So let's figure it out. A lot of times you'll see an arrow on there. It's either going from the top left to the bottom right or vice versa, right?
Right.
Okay. So the way we can figure it out is let's try t equals 0. What's x when t equals 0?
X when t equals 0 is, so -3 sine of 0. Sine of 0 is 1.
No.
So
Sine of 0 is 0.
0. So
Cosine of 0 is 1.
Yeah. So it's 0.
You need to lock those into memory, because that comes up so often in calculus, where you're taking the sine of 0 or the sine of 1 and the cosine of 0 or the cosine of 1. So make sure you get those right, okay? So if sine of 0 is 0, then I got 0 minus 0, so x has to be 0. Well, there's an x of 0. I still don't know which way it's going, but one more point and I will know. Let's try a t of 1 and see where my next point ends up. If it's to the left, I'll know the orientation. If it's to the right, I'll know it's going counterclockwise. Well, when I plug in t in for the x equation, I get 1 minus 3 sine of 1. Is sine of 1 a positive or a negative number?
Positive.
Yeah, here, let me just draw the sine curve. It's like that. And this point right there is pi over 2, which is like 1.56, correct?
Yeah.
So what the heck? Let's use 1.56 for t. That'll actually be a better way to do it. Because we know what the sine of 1.56 is, right?
Right.
The sine of 1.56
is pi over 2. Or no.
What's sine of pi over 2?
Sine of pi over 2 is 1.56.
No. 1.56 is pi over 2 in radians.
So sine of pi over 2 is 1.
Okay. So the sine of 1.56 is 1.
Right.
Okay. So 3 times 1, subtracted 1.56. We've got negative 1.44. That's what x is going to be equal to when t is equal to 1.56. Well, that puts that x clearly somewhere over there. Puts it on the left side of the y-axis.
Right.
And that tells me how to orient this parametric equation. It's going like this. And you never see the rest of that curve. Because for one thing, when I put it in to Wolfram Alpha, I didn't say t goes from 0 to 12. So they just drew a bunch of it. They probably had their t going from negative something to something else. But as all I need to do is have a first point and a second point, and I know that is the direction that it goes.
Okay.
Now I am curious what would happen if I put that in there. Let's see. Hold on. Comma. 0 less than t less than 12. Let's see if that gives us what I'm looking for. In fact, it might even draw it out so we can see it, trace it out. It does not. However, notice down here, the curve that you're looking at is t going from minus 3.299 to 6.283.
Right.
So this must not have been the way to put in the t parameter. I don't know how to put that in. Maybe if I put in parentheses around it, that would do it. Let's see. And then it would only give us half that curve, maybe. Still goes. I must not be putting it in right. But nonetheless, once you figure out 2 points, you can tell which orientation it's doing.
Okay.
Okay. Now, set up an integral to calculate the total length of the path the plane traveled. So we know that from above the ground, it looked like it traveled that way, right?
Right.
In other words, it looks like it took off and then started doing curly cues. In other words, at time equals 0, the plane is right there. Hold on. At 1, or 1.56, it's somewhere like that. So they want the length of that arc, and I don't know where that thing ends. I don't know if it goes like, no, it doesn't go all the way, because this one, t only goes up to 6.28. Whereas in our problem, t goes up to 12. So if I want to calculate the path of that, there is a formula for that. And it is the length of the arc, which is, we have used s before in regular calculus.
Right.
And what goes inside is 1 plus, no, excuse me, when you have a parametric equation, what goes inside is dx dt squared plus dy dt squared. It's actually pretty simple to remember. And is dt. And we're going to go from t going from 0 to 12.
Okay, so
right.
We have to take the
Now,
derivative of this.
We need a dx dt, right? So
right.
Let me erase this. Tell me what dx dt is.
Dx dt. So that would be, I'm taking the derivative of t minus 3 sine t.
Correct.
So it would be 1 minus the derivative of negative sine is...
I've already taken care of the negative sign. I got 1 minus. It's the derivative of that.
The derivative of 3 sine t would be 3 cosine t.
So that's dx dt. What's
right.
dy dt?
So then dy dt equals 3 sine t.
Good. Yeah, a person can't even begin calculus unless you're really good at trig.
Yeah.
So, I mean, you can begin, but you can't get very far.
Right.
So, dx dt squared 1 minus 3 cosine t squared plus dy dt is 3 sine t squared. All of it. Let me erase some stuff so I can. Now, usually these aren't particularly easy things to integrate, but I suspect this is going to be. Let's see.
Would these problems typically be calculator problems on the AP Calc BC exam?
I don't think so. You got to be able to set this one up first. Yeah, you might be able to do a definite integral of this. You might be able to put that into your calculator. You have an Inspire or a TI-84?
TI-84.
Then you'd want to put in definite integral. It's one of your functions on the main. I think it's number 9.
Yeah.
And then the format that you put it in is critical. I think you have to put the function, which would be all of this, comma x, comma 0, comma 12. I think that's the way it works. You do definite integral, you choose that option, and then you follow that with f of x, comma x, telling it it's a function of x, comma your lower limit of integration, comma your higher limit of integration. Let's just take a quick look at this. It might be this solves easily. Whenever you see a cosine squared and a sine squared, you know you're going to be able to combine those and get the number 1.
Right.
So, if I expand the first one, I get 1 minus 6 cosine t plus 9 cosine squared t. And then if I add to that 3 sine t squared, that's sine squared of t also.
Right.
Doesn't look like I can do much with that. I'd hate to have to integrate that. So yeah, I guess this is where you use your calculator.
And I did put it in the calculator and I got 24.1, which seems right.
24.1 as a total path traveled and going like that, and it clearly goes beyond that because that's only t of 6.28. So
right.
Probably is something like that. Well, that's a radius of 3, so pi r squared would be 20, mid-20s. So yeah, it's definitely a ballpark. In other words, the circle that I just drew would have a circumference, it'd have a circumference of 2 pi r, which would be pi times 4 times 2. So it's still ballpark. It's 24 approximately.
Right.
Yeah, I don't know. I don't know if I know how to do that one. I was thinking I could factor out a cosine squared plus sine squared, turn that into 1. I still got this one over here to worry about. So
right.
This might be one where you would have to use the calculator. The key thing on this problem is knowing that formula.
Okay.
That formula is pretty easy, actually. It's the square root of dy dt squared plus dx dt squared. That's it.
Right.
Okay. So C is actually pretty easy. Dy dt. What did we say dy dt was? Hold on a second.
It was 3 sine t.
I keep making the same mistake. So if dy dt is 3 sine t, what's dy dt when t is equal to 7? Whatever that is.
Sine of 7, I'm not sure.
Well, your calculator will tell it to you. Remember your calculator, as long as it's in radians, calculus requires radians. It does not work in degrees.
So 3.
The derivative of sine is not cosine if it's in degrees. Only cosine if it's in radians. Well, that's close to 2 pi. 2 pi is 6 point something.
So 3 sine
I would give this answer right here. That's the most exact answer you can give. Any other answer is going to be rounded off.
Right.
And dx dt is, what do we figure dx dt was? 1 minus 3 cosine t?
Yeah.
So 1 minus 3 cosine of 7. That's what I say. Number C is a lot closer to differential calculus, not parametric calculus.
Right.
In other words, you take the derivative and you plug it in. Explain what those values tell you about the flight of the plane.
I'm not sure on that. I'm kind of confused on what that would do.
Okay, let's see. dy dt is going to be the change in vertical distance with respect to time.
Okay.
So that again was 3 sine t. And when t is equal to 7, it's that. That's going to tell you where the y position is at the end of 7 seconds. Let's look at my other picture. In other words, here's what's going on. Here is where the plane starts at 0 seconds. One moment. And we know it's going this way. Now, I don't know where 7 seconds is on there, but what did we get? 3 times sine of 7?
Yeah.
So if the original y coordinate was at 1, which it is, in other words, when t is equal to 0, y is equal to 1, then at the end of 7 seconds, we've got 3 cosine of 7. Well, cosine of 7 is close to the cosine of 2 pi. It's a little bit more. We know the cosine of 2 pi is 1. So this has to be close to 1. Remember, the cosine curve goes like this.
Right.
So the cosine of 7, if I take away 6.24 there, then we're looking at a point like right there. So that value is going to be greater than 1. 3 times that value.
Right.
So what that means is if when t is 7, y is 3 cosine of 7, that tells you the y coordinate has moved from 1 to whatever that number is. And we can see that that's what's happening as we go count forward. In other words, I don't know where t is 7 is on here, but it's wherever the y coordinate is 3 times cosine of 7. Do you have your calculator handy?
Yeah.
Tell me what 3 times cosine of 7 is.
2.26.
So actually, it's only moved up to right there. So at the end of 7 seconds, ooh, that's a little scary.
Yep.
I say it's scary because this thing goes up to 6.283, which is right there. No, that's actually about right. The y coordinate's pretty close.
Right.
So my question is that as t counts up to 12, this thing, there it is at 0, there it is at 7. Got to make this entire path plus more by the time t gets to 12.
Right.
So this thing is not linear. In other words, it goes this distance from 0 to 7, and it clearly goes this distance or more from 7 to 12.
Right.
Guess that's okay. It doesn't have to be linear. This makes me feel like I might have made a mistake somewhere.
Mr. Cohen?
Yeah.
I'm going to have to go. I have a baseball practice.
That's fine. I wasn't looking at the clock, so
it's okay.
We can finish this up next time.
Okay, yeah, and I'll send you some more for next time as well.
Sounds good, John.
All right, thank you so much.
Bye-bye.